screen, we're doing dilations. You have to have a ruler and a calculator and a pencil. That's what that says. After this lesson, you should be able to successfully, well, yeah, that's really worded poorly. I need to fix that. Anyway, you're supposed to be able to dilate figures, and we're going to show you how. You're probably familiar with the word dilate as it relates to your eyes. The pupils of the eye were dilated. As the light hits the eye, a pupil enlarges or contracts, depending on how much light is coming in. So this concept of enlarging and contracting is dilating. So like they put the drops in your eyes when they're trying to look in past your iris. They're trying to look in past it into the back of your eye. And that is dilated, enlarged, if you will, from what it is if the light's bright. Okay, when the bright lights shine in your eyes, your eye or pupil contracts. So it can be an enlargement or an expansion or enlargement or a reduction. So a dilation is a similarity transformation. It is not a rigid motion. What that means is the figure will still have the same shape. It enlarges or reduces the figure proportionally. A dilation is not a rigid motion or isometry. A dilation produces an image that's the same shape as the original, but not the same size. Dilations are completed with respect to a center point and a scale factor. Okay, don't have things to fill in much on your paper today. A dilation is similar to the original figure. Most dilations are centered about the origin. That's when you're in the coordinate plane. The scale factor determines how much larger or smaller the dilated image is than the original figure. If the scale factor is greater than 1, then the figure becomes enlarged. If the scale factor is between 0 and 1, then the figure will be reduced. So numbers that are between 0 and 1 would be things like half, a third, or these are just examples. Say 0.2, you can have decimals, all right, also. When 0, 0 is the center of dilation, you multiply the x and the y by the scale factor. So you multiply by the scale factor. And F they're using for scale factor here. It might be some other letter as well. And in the case of today, most of them are R, the letter R. A rate of scale factor. I don't know why they use an R. Let's just look at this example. This is actually going to be in our ISN, but I want to explain to you what's happening before we try to do it. So see, if O was the center of dilation and it's said to do a scale factor of 2, that would mean that you want to make B prime be twice as far away from O as B is. So you would measure from O to B, and then you would take that measure and you would multiply it by the scale factor of 2, and you would make a mark that far away. So we're going to be lining our ruler up. That's where you're going to put your ruler at 0. And so let's check it out. We're going to do a physical one. I'm ready now to do it. I'm going to do one actually on the paper. So I'm going to bring out my document camera here. If I can get it to open up, which it did earlier today, so let's hope it works again. Open. There it is. Okay, I'll maximize it here so you can see what I'm going to do. So I've got my ruler. Sorry for the little bit of delay. I'm going to use the millimeter side so that we're all doing the same measurement. It would be best if you did the same thing, please. I'm going to put where my ruler says 0 right on S, and then I'm going to line up through to where the point A is. I'm kind of putting the center of 0 right in the center of the dot. Okay, and then I'm going to measure from there to point A. It looks to me like that's about 1.7 centimeters. Is that what you guys are getting for measurement? Okay. So what was our scale factor? Well, it says right here the scale factor is 2. So we're going to take that measurement again, put it back if you moved it. Make sure you're lined up. You see your 1.7 measurement, And we're going to do the scale factor 2 times our 1.7, which is 3.4. So you hold your ruler still, and if you want, you can even make a line out till we get to 3.4, and then we're going to make a dot there and write A prime. You don't have to make that line, but if you'd like to, that would be fine, and some of you will like the way it looks. Okay, now we're going to do the same thing for B. As you notice, I have another broken ruler. I really wish people would stop bending my rulers, playing with them, and breaking them so that we can't use them. We're running out. Okay, so I'm going to measure now by, again, putting 0 in the middle of S, that big old dot, and figuring out how far it is to get to B. Are you guys getting 1.6? Okay, so let's do 2 times 1.6 now. That's going to be 3.2. Hold your ruler still. Go out to 3.2, make a dot, and label it B prime. And if you want to connect those, that's fine. Everything should be on a straight line. Okay, but now we really do, since we were blowing up segment AB to segment A prime, B prime, we need to connect A and B. And there we did it. So all that is B prime and A prime are twice as far away from A and B. So number 2, it says the R is 1/2. That's going to mean we're going to take our measurements and divide by 2. That would be the easiest way, or multiply by 1/2. So we're just going to go from, again, 0 on our S, whatever your center of dilation is. In this case, it said to dilate as a center of S. Okay, and that I find T to be about 2 point, would you say that's 2.5? Okay, well, we got to take half of 2.5. That's kind of a weird number to take half of. But if we do take half of 2.5, that would be 1.25. Okay, we can estimate where 1.25 is. We just go, keeping our ruler still, go out to 1, go out 2 more marks, and then go in between the 2 and the 3. Gosh, you can barely make a thing big and small enough to actually mark a 1/2 millimeter. This would be T prime. And now we need to do it for C. We're going to measure from S to C. I got 2.8. Okay, so we're going to do 1/2 of 2.8, which would be 1.4. Okay, so I'm going to make a mark at 1.4, 1, and then 4 marks past the 1. And that's C prime. And then we'll just connect T and C. Now, what happened is the segment TC got smaller, okay? It shrunk towards S. So it's going to go away from your center of dilation when you're enlarging. It's going to go towards your center of dilation when you're reducing. Okay, we got one more to do, and its scale factor this time is 1.5. So all of our measurements will be multiplied by 1.5. We're probably going to need a calculator for that. Okay, so I'm going to go ahead and measure first from S to C. That's kind of a big dot. I'm just putting my 0 in the center of it. Oh, I got 2 centimeters, do you think? All right, let's go with that. So we're going to do 1.5 times 2. Our measurement, our R or scale factor times your measurement. All right, 1.5 times 2 is 3, right? Okay, so let's go from the center. We've got to make a mark at 3. Make sure you held that ruler straight in line. If you want to make lines through S and C all the way to your mark, feel free to do it. Kind of made my mark really big, but don't forget to label that C prime. Okay, let's go from S to R now, so we can all compare measurements. I got 2.3. Okay, so let's do 1.5 times 2.3. I definitely need a calculator for that, I'm thinking. Oh, it helps to turn your calculator on. 3.45. Okay, so I'm going to hold that still. 3.45. I mean, gosh, just get it right between the 0.4 and the 0.5. Label that R prime. And we got one more to do. Should have a bigger measurement this time. Can we go with 5 or 5.1? Really should be like 5.1, shouldn't it? Okay, so I got to do 1.5 times 5.1 centimeters. I got 7.65. I'm just jotting it down so I don't forget. So I'm going out from here, keep going out 7.56. Well, just make a mark between there. Between 7.6 and 7.7. All right, there's your T prime. Oh, I kind of had connected before. Maybe I'll still do it. All right, these should all line up on a straight line. All right, and then connect your prime points. I don't know, my figure, that came out really dark. Anyways, there we go, a dilation. Kind of looks neat. Now, I can go back, because we're going to go into the coordinate plane. I'm going to go back to my brighter screen. And our first step here is going to be, we need to plot the original figure. Are we good? I hope I didn't go too fast. I thought I went, maybe I went too slow. Not sure. Hopefully a good speed. All right, plotting points. Remember to be careful plotting your points correctly. X comes, then Y, so left or right, and then up or down. So -2, -2, point A, -1, 2, point B, and 2, 1 for C. Grab your straight edge and connect them. Okay, and then I'm going to be dilating with a scale factor of 2. What you do is multiply all the values by 2. So A prime is going to be at -4, -4. B prime is going to be at -2, 4. And C prime is going to be at 4, 2. Now that we know where the points are, we can go ahead and just plot them. I went the wrong way. -4, left 4, down 4, A prime. Left 2, up 4 for B prime. And 4, 2, C prime. So these look different, and that's because the center is not it's outside. It's not outside the figures like the ones we just did a few minutes ago. The center of the dilation is the origin. So everything's blowing out from the origin. So you know how we connected those lines before? Our center of dilation for these problems, I'm going to highlight it. I'll show you what I'm talking about. Our center of dilation for these problems is the origin. So if you, well, that just wanted to wiggle my picture, and I just want to fix that. If you wanted to connect B through B and B prime, it would go from the origin, through the origin. So it's going out from the origin. Any of these are on any line that connects the origin. Okay, so that's how we're dilating it. You do not have to make those lines, although, has anybody done taken art class and done perspective drawings? Yes. Okay, dilating away from the center is like a perspective drawing, is right? You have a point of perspective, and then you blow up everything out from that. This is not that. It's in a way related, but it's out from the origin, so everything's going out away from the origin. I liked art class as well. Those of you who are into art. Got a lot of geometry in it. Yes. Very helpful for you to understand geometry to be good at your art. All right, number 5. Not that you have to, but it helps. You got your 5 points, holy crow. Let's go ahead and get those plotted and labeled. Don't forget to do your labeling, people. Points on that. You do get points for not labeling in the quizzes or tests. So you want to make sure you're labeling everything. And then drawing it in. It's going to look kind of like geometric shapes put together. A rectangle and a triangle. Sort of looks like a real basic house turned sideways. Okay, what will I do with this scale factor? What would be a scale factor of 1/3 do? Shrink it or enlarge it? Okay, shrink or reduce. It's a reduction. Okay, now how much are you reducing by? You're reducing by 1/3. You're taking 1/3. Now, what's the easy way to think about taking 1/3 of something? Multiply by 1/3 or divide by 3. Okay, divide by 3 would be the easiest way to tackle this one. So A prime, when you divide 0 by 3, you still get 0. So 0, 0, A prime's not going to move from where A was. B prime, though, if I divide 3 and 3 by 3, I get 1, 1. And C prime, 6 divided by 3 would be 2, and 3 divided by 3, 1. E prime is going to be 2, negative 1. And E prime is going to be at 1, negative 1. So get busy labeling and plotting. Oh, let's see, where B went to 1, 1. B prime. 2, 1, C prime. Wow, this is tiny. 2, negative 1 for D prime, and 1, negative 1, E prime. So I got one tiny little figure to draw there. But it stayed inside the other one because it shrunk towards the origin. And A was at the origin, so it didn't move. Anybody still need this? I can wait. Okay, let's go to the next one. start plotting those points. You can go ahead and plot and just check and make sure you plotted correctly. Tell me if I made a mistake. Okay, make sure your original figure's in the right spot. And now check out the scale factor. It says 0.5. What does 0.5 mean? Does anybody have any, like, all right, let's think about that decimal. 0.5 is 5/10, right? Which reduces to 1/2. Or you can just, if you don't get that, you can just multiply 0.5 times -2 and you're going to get it. But it's just like you are dividing by 2. So E prime should go to -1, -1. F prime should go to -1, 2. G prime should go to 1, 2. And H prime should go to 1, -1. Shrinking towards the origin. There, we all set? Anybody need me to hold off? Nope. All right, let's try another. I think we just have a triangle next. Yep. But these numbers are going to get pretty big. I can see that. The grid's big. A for 6. 5, 2 for C. Now I have a pretty small triangle to start, but it's going to grow because our scale factor is 2.5, and that means we're going to multiply the coordinates by 2.5. Let's see where they go. So I got to do 2 times 2.5, which is 5. So the first A prime can be at 5, 5. Then I need to do 4 times 2.5. So that's 10. And I got to do 6 times 2.5. What's 6 times 2.5? I get 15. Good. You can do that in your head, huh? Good for you. Me too, but I practice a lot. And then I got it. I know some numbers I wouldn't feel like doing, but 5 times 2.5, that's 10, and 2.5, so that'd be 12.5. And then we already did 2 times 2.5, which was 5. All right, so carefully plot those points. And label with prime notation. Twelve and a half, 1, 2, 3, 4, 5. Shape should stay the same. All sides should be parallel to the originals. And it's just blown out away from the origin. All right. So next we're going to figure out the scale factor. When you do a scale factor, you need to compare new to old. That gives you your scale factor, SF. If Leila drew a polygon with coordinates, blah, 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 negative 1, 2, 1, 2, 1, 1, negative 2, negative 2, negative 1, negative, whatever. I don't need to read them all. He then dilated the image and obtained another polygon whose coordinates were the following. Had a lot of 6s and 12s. What was the scale factor then? Now, how do you know it's scale factor of 6? Okay, so these are my new points, right? I just want to show everybody how to get it for sure every time. Instead of 1/6, I wanted to know why you knew it was 6 over 1, because it could be one way or the other. It doesn't always have to be bigger over smaller. Right, see, these are the old points. These are the new points. No matter what pair you take, you can do negative 6 over negative 1. That gives you 6. Or you could do 12 divided by 2, which gives you 6. Any pair. Corresponding points. Okay, so 6 is the correct scale factor. Good job. And the center of dilation would be the origin, which is 0, 0. So if you multiply the coordinates, the center was the origin. Now, 9, you've got a picture. We need to figure out which one's the new one versus which one's the old one. Which figure is the new one, and how can you tell? How do you know for sure it's the bigger one? Because it doesn't have to be the bigger one. It's labeled with what? The prime notation. Okay, because that's prime notation, this is the new figure, and this one is the old figure. So, this is an enlargement. It's an enlargement because the figure got bigger. Now I want to find out the scale factor. Okay, so what you want to see is that from all the way from the center dilation to the new figure is 7 units. This piece is 5. What would the X piece be if the whole thing's 7? The X plus 5 must equal the 7. Agreed? That whole length would be that plus that. So if you subtract 5, you get X is 2. Okay, now, to do the scale factor, the old measurement was 2, whereas the new measurement is 7. So it's new 7 over old 2. 7 over 2 is the scale factor. You could write 3.5 instead, or you could just leave it 7 over 2. Okay? You have to pay attention now which one is where. Like, you have to look for that prime notation. So don't assume it's always the bigger one that's the new one, because look at number 10. The new one is the smaller figure. The bigger one is the old figure. So this is a reduction. We got to compare new measurement to old. So we're going to have to go over to here to this other side. The old measurement was 5 units. So that'd be on the bottom. And the new one is a 2. So 2/5 is the scale factor. If you divide that out, you can write 0.4 if you want instead. Okay, but that's how you find it. Now, what would X be? I don't know why we need it, but what would X have to be if 2 is here and 5's there? 5's the whole thing, 2 is part of it. So this would be 5 minus 2, which is 3. We had no purpose for that, but we found it anyway. Okay, it's time for you to practice. You've got some rulers and stuff, so let's get that done now because you may not have a ruler at home. So please do the ones that require your measuring with the ruler. You can do the ones with the graph paper without measuring. So let's go. Tomorrow we'll fill in our ISN and we will be getting the review for the unit test, which is going to be on Thursday. So I wanted you to know that we aren't doing a second quiz this unit. We're going to go ahead and get through the unit test because we've got quite a bit to do before final exams in December. Over and out.